questions. If you don't know, you don't know. Don't be afraid to say, look, I don't get it. Can you run that back? I do respond to your request. Okay. I do respond to your request. Don't know. Don't be. So now that's up and running. So as you guys can see, we're ready to go. Let me go ahead and screen share so you guys can have access to that as well. I have prepared my notes diligently for you guys so that we don't waste any time answering questions. Okay. So yesterday, okay, Tyler, you said you just failed your chemistry exam about molarity, titrations, and concentrations. Why didn't you come look me up? I could have had you getting on the right track. Okay. Yes, I could have helped you out. I'm so sorry. But, there's always the final exam. So if you need help, you better come and find me. Speaking of which, I have students that hit me up in my DMs all the time asking for tutoring. If you guys need additional tutoring, you all can hit the link in my bio. Okay. Hit the link in my bio and it'll take you straight to my website where you can book your tutoring session. But more importantly, you can always, get what you need individually. Or if you want to continue in this format, you can do that as well. Okay. So, and again, for those of you all that want to follow me on YouTube, you can do that at Learn Chemistry. Okay. With Professor TK the Chemist. Okay. So if you want to get the help, Learn Chemistry with Professor TK the Chemist. You said thermodynamics was the worst. It's actually not that bad. Now, I'm going to be real with you. It's not that bad. The thing is, you've got to remember, of course, the formulas, but all you're doing is flipping the reactions and using coefficients to balance the chemical reaction in order to add them up. Like you're getting the sum of your products and your reactants. So, yeah. Now, if you said you're thinking about taking General Chem 2 during the summertime, let me just say this. You shouldn't have a job. If you're working, you have to still put in the work with your chemistry classes during the summer. It is not easy during the summertime because your teachers are condensing 16 weeks into 4 to 6, depending on where you're at. Hello, Iconic, how you doing? So yeah, I just wanted to kind of show you. Hey, Steve. I just kind of wanted to show you guys how it is doable to do chemistry during the summertime. Yes, 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 yes. But again, the expectation is it is at an accelerated pace. And because it's at an accelerated pace, your teachers are going to assume you don't have a life and that you're dedicating all of your time to their class during the summertime. Okay, Brooke boy. Okay. Oh, Brooke boy. Okay. So yeah, I mean, I try to balance it out between General Chem 1 and General Chem 2. But starting next week, I will go live again, Monday through Thursday. The time for the live in the evening time is still up in the air. I know many of you guys may be from different coasts. Matter of fact, can you all put in the chat box what set you claiming? Are you from the East Coast, North, South, West? What state are you from? So go ahead and put that in the comment box while I'm preparing my screen for you guys, okay? Go ahead and put that in the comment box. Where are you guys from? Where are you all from? All right, Amber, North Carolina. That's right. North Carolina, go ahead and raise up. Okay, Tyler, you're from the East Coast? Oh, Iconic is from Alabama. Okay, New York, New Jersey. Okay, very good, very good. I get a lot of requests from Cali. I get a lot of requests from Cali, believe it or not. And right now in Cali, it's like 9 o'clock in the morning. Yes. So you guys are coming from everywhere. So this is the deal, though. I know I'm hitting different coasts at different times. And I do go live Monday through Thursday at 12 noon Eastern Standard Time. So if this time doesn't work for you, like you're on your lunch break and you just hopping in and bobbling back out, it's okay. You can always go back and look at the video on my YouTube channel. And it goes live with me. The only thing you have to deal with, though, is a commentary. So that's the only problem. You know, I don't edit the videos on YouTube. I just let them play out. So you can kind of skip and get through what you want to, do in terms of that. Okay. So are you guys ready to get it in? I'm ready. Let's get into it. So today we're going to get through some of these problems that we were talking about last week, or this past week rather. And we've been dealing with enthalpy, Gibbs free energy, entropy, and all of that. And I know that many of you guys have been on the struggle bus with this particular topic, but I'm trying to show you guys that there is an easy way to digest this material. There is an easy way to digest this material. So all you got to do is just look at what you got, okay? Follow the steps and breathe in, breathe out, okay? You don't have to overthink these problems. So today's lesson is going to summarize what we've talked about all week in terms of enthalpy. This is like the thermochemistry lesson, and we dealt with Hess's law. And so today we're going to, kind of summarize all of that with several problems that we dealt with throughout the week and what I'm going over today. So you're going to have a mixture of problems because on your test, your teachers are going to do the same thing. They're going to put all these different types of chemical reaction problems on there, and you just have to be able to, answer the questions and, go with it. So on the screen, okay, the first thing I have is a chart. Many times you'll be given problems where you'll have to refer to a chart for certain items. So if it says refer to the table for your heats of formation, then this is an example of that particular type of table. Every book will have the table written differently, but it's up to you to determine how to use this chart, okay? It is up to you to determine how do you use the chart. So what you've got here is this formula that I put here on the screen, where the heat of formation is equal to the sum of the products minus the sum of the reactants. So if I tell you to calculate delta H for the following reaction, if this is all you were given, okay, let me zoom in a little bit for you guys on TikTok. Okay, if you all were given a problem like this and I said, determine the delta H for the following reaction. If this is all you're given, the first thing you want to make sure is that it is balanced, okay? That it is balanced. Why? Because you have to use those coefficients to solve a problem such as this nature. So in this particular case, though, it is balanced. So we can actually go ahead and go through the problem. You have to go to your chart and find the heats of formation for each of these individually. Now, because you see where it says it's the products minus the reactants, your reactants will always be on the left-hand side, okay? And your products will be on the right-hand side, okay? Keep that in mind. So I'm going to pull this chart down so that you guys can see what they are for each of them. So we've got calcium carbonate, calcium oxide, and carbon dioxide, okay? We've got all three of those that we're going to look at our chart for. So I'm going to pull the screen down, and let's see what we can do to answer these questions, okay? So here we go. All right, so right here you've got calcium carbonate. So let me just highlight it so you all can see. We have calcium carbonate, which is negative 1207.6 kilojoules per mole. We also have calcium oxide, okay, the solid form, negative 634.9. And then we have carbon dioxide in the gas form, negative 393.5. It is important to know which physical state your items are given, because, for instance, if you look at water, okay, if you look at water as an example, water is either in a gas state. I don't know why my little marker ain't trying to work now. Water is either in the gas state or the liquid state. The thing is, the numbers are very different. So you want to make sure that you are able to do what? You want to make sure that you're able to use the correct number, okay? That's what you want to make sure that you do. All right, so now let's go ahead and go to the next part of the problem, okay? This particular page here, this is in most chemistry books. So whenever you're doing a problem of this nature, they will give these problems to you, or this chart to you. So this is a chart that you would actually find in your textbooks. It's usually as an appendix, or it may be within the chapter. So this is not something that, you have to go and search for, but it's something that's given in most of your chemistry textbooks for this particular topic. Now, since we've got those three numbers right there, okay, I'm going to go ahead and write them down again so that you guys can see that, okay? You were given calcium carbonate, and you were given calcium oxide and calcium dioxide. So you've got negative 1207.6 kilojoules per mole. You were also given calcium oxide, which is negative 634.9 kilojoules per mole. And you were also given negative 393.5 kilojoules per mole for carbon dioxide. Now, here's what you're going to have to do, okay? You're going to have to combine the products together, okay, in order to get your answer. So when you're doing delta H, these are the values for each of these individual elements here, okay? These are your heats of formation. So what you're going to have to do is calculate, of course, like I said before, your products and your reactants. So if I were to do the product side first, this is what I would have. Negative 634.9 minus 393.5. So I'm going to do that side first. I like to keep things together to make it easier when it comes to solving these problems, okay? So that's negative 634.9 minus 393.5, okay? You end up with negative 1028.4, okay? So this is equal to negative 1028.4, again, kilojoules per mole. Now, if we go back to the formula that I just told you guys about, okay, right here, it's the products minus the reactants. So what I'm going to do, as I show you this right here in terms of getting your answer, because it is products minus the reactants, okay, delta H is equal to the products minus the reactants. What you're going to do is take the products right here, okay? You had negative 1028.4 kilojoules per mole. Now remember, because I'm going to bring this to the other side, that negative right here, this negative, because we're going to bring it to the other side, okay, that sign is going to change to a positive. So that becomes plus 1207.6 kilojoules per mole, okay? So now let's go ahead and plug this into our calculator. Okay, negative 1028.4 plus 1207.6, and you get 179.2, okay? 179.2 kilojoules per mole. And as you guys can see right here on the screen, that's the answer also. I like to show the answers so that you guys are able to check it also for those of you all that are doing the problems right beside me, right along with me, okay? So that is your answer right there. Thank you, Matt, 8ball8. Okay, Iconic says, can we do one where we have to solve for the heat formation of a certain compound for the delta H? Okay, so here's the thing. In order to solve for something like that, it's really simple. Like, for instance, if you're given the total sum of this heat or formation, like this is the total sum right here, the 179.2. And I asked you to find, let's say, I'm going to put this in a different color so you can see it. If I tell you to find carbon dioxide, for instance, you're just going to replace this 393 here with an X, and you're solving it backwards. So you're still able to do the same thing, whether I give you part of these elements or not, okay, or the compounds. You can just place that as an X and work backwards. So it's almost equivalent to saying, okay, for instance, if I told you X plus 3 equals 9. So if you know one of those variables, okay, well, let me say this, 2 plus X plus 3 equals 9, as in an example similar to what we're doing. As long as you know 3 of the 4 numbers, you can solve for that unknown. So I know that 2 plus 3 is 5. So it's like you're saying 5 plus X equals 9. And when you subtract 5 from both sides, you're able to say that X is equal to 4. So in other words, you're still able to solve for your unknown, even having given part of the answer or part of the problem. So as another way to look at this, okay, if I told you that you were given, let's say that chart again, okay, you can still prove that carbon dioxide's value of negative 393.5 is that answer. So you can still go back and do that. Oh, you're welcome, Iconic. You are welcome. So yes, you can still isolate one to solve for the other. Now, you know we got another one, right? I believe in giving multiple examples to make sure that you guys can get it. Okay, so take a look right here now at the next problem. Okay, it says, again, calculate the delta H for the oxidation of iron 2 oxide to iron 3 oxide. So they give you the chemical reaction and it is balanced. But again, always make sure that your equation is balanced before you do it, because if not, that's going to throw your answers off. And I'm going to show you how that is. But first, we need to find the heats of formation for iron 2 oxide, oxygen gas, and iron 3 oxide. So let's go ahead and go back up to our chart to look for those items, okay? So I'm going to go ahead and erase what we were using before, because now we're on to a new product. So we had iron 2 oxide, iron 3 oxide. So here's iron 2 oxide. Here's iron 3 oxide. And oxygen. That's set to 0. Keep that in mind, okay? Keep that in mind. And yes, Iconic, yes, we will multiply that by 2. Yes, you are 2 steps ahead of me. You are absolutely correct about that. So these are your numbers here that we're going to use. So let's go ahead and remember them and pull them into this problem. Okay, so now if you guys don't remember, guess what? I got you. I got the numbers already written down for that reason. Okay, so here we had, again, 2 times. So when I put the delta H right here, okay, that's going to be 2 times your heat of formation for iron 2 oxide, which was negative 825.5 kilojoules per mole, plus, and for your oxygen, remember, that was just 0, okay, equals, okay, the F2O3, which was negative 1118.4 kilojoules per mole. Now, again, remember, the formula, okay, if you all remember, the formula is what? What again? Products minus reactants. Products minus reactants, okay? Products minus reactants. So if you can remember that, that's going to be very, very helpful. Products minus reactants. And again, if you don't remember the sides, that's a problem. Your reactants are right here on the left side. Your products are on the right side. So if you know that it is the products, okay, minus the reactants, watch this. I'm going to take the negative, okay, because this is a product right here, the delta H The product is the negative 1118.4 kilojoules per mole minus. Now, right here, you've got a negative. When we take that 2 times 825.5, let's do that now, okay? 2 times 825.5, that was a negative. You get 1651. 1651 kilojoules per mole. Now remember, when you have two negatives, what does it become? If you remember, when you have two negatives, what does it become? It becomes a positive. If you didn't know, now you do. So you got negative 1118.4 kilojoules per mole plus 1651 kilojoules per mole. Now let's plug this into our calculators so we can get the answer. You have negative 1118.4 plus 1651, and you get 532.6, but we're going to round that off to 533. So 533 kilojoules per mole. Okay. Oh, I know. I'm still here though. I'm still here. So even if you're taking chemistry, whether it's one or two, tell a friend to tell a friend to tell a friend. Make sure you guys continue to hit that screen and also share this out with your friends. Share this with other people that you know that could benefit this. I am also on YouTube right now. Okay. So for those of you guys that have to dip out, because I know several of you all have expressed the need to see these videos over and over and over in a different way, you can always go to my YouTube channel. Remember, I am on YouTube at Learn Chemistry with Professor TK the Chemist. Okay. So if you need to get this again, because you have to dip out, by all means do. Okay. That is my YouTube channel right there. And you can also go to the link in my bio and that'll take you to that as well. Okay. Yes, Sunshine Girl, come on. Come on. Yes. Yes, yes, yes. You can binge watch me, right before you take your test. All right, guys, let's do another one, and another one. Okay, so this one right here, it says, determine, again, delta H for the following reaction. Again, you just got to go back and use that chart. So, and again, make sure your equation is balanced, which in this case, it is balanced. So now let's go ahead and do what? We need to go to the chart and find NH3, HF, and NH4. Okay, so I'm scrolling the screen back up again, and I'm going to erase what we've already used, okay? So we're going to go ahead and get rid of those because we don't need those anymore, but we needed NH4F. We also needed NH3. And what was that last one? Let's see. The last one was, HF, which is right here. Okay. All right. So now you've got these numbers. And remember, again, I always will reiterate the formula, okay? The formula for those problems, once again, are the products minus the reactants. And you just got to know which side is which, okay? So again, products minus reactants. And I'm just going to give a quick abbreviation for it. Products minus reactants. Again, your products are on the right side. Your reactants are on the left side, okay? Now, here is the thing though. The numbers that were given, in case you forgot, in case you didn't know what the numbers are, NH3 was negative 319, okay? No, not 319, Scott. Sorry, y'all. The numbers for NH3 was negative 45.9 kilojoules per mole, plus the HF is negative 273.3 kilojoules per mole. And then on the other side, you had NH4, which was negative 125 kilojoules per mole, okay? So remember, because you know it's products minus the reactants, the first thing you need to do is solve for the one side that has all the numbers together, okay? So we're going to put these two together right here. This part right here, we're going to go ahead and do that operation first. Negative 45.9 minus 273.3, okay? So again, you got negative 45.9 minus 273.3. And that gives us negative 319.2 kilojoules per mole. Now remember, since I know the formula says products minus reactants, okay, products minus reactants, I'm going to write my delta H and put it like this, negative 125 minus. Now remember, if I bring this minus sign on the other side of town, it's going to become a positive, okay? So I'm going to put this here in parentheses so you will see that. When I say minus, I'm going to put positive 319.2, okay? Kilojoules per mole. And remember, because it became a positive sign right there, what you're going to do, okay, is plug those two together. All right, plug those two together. Okay, so again, just to make sure that we understand where we're coming from, you've got negative 319.2, okay, plus, and remember, that becomes a positive sign right there, okay? That becomes positive because you're bringing them together, okay? So you've got 125, negative 125 plus the 319.2, and you get 194.2, okay? 194.2 kilojoules per mole, okay? Any questions before we continue? Any questions before we continue? You're welcome. I'm glad this was helpful. Thank you, not for Z3D. It is that simple. You know, I don't believe in giving all these additional steps unnecessarily if we don't have to do that. So I try to make it easy because I know some students really do struggle with trying to get it. So let's do this. We got some more problems that I'm going to actually add to this lesson. Okay. Listen to you, Devin. I'm going to go ahead and show you all another thing of what we talked about yesterday, which is going along with what we discussed, what we're discussing today. Okay. So now when we talk about enthalpy, those problems are actually easy too. So as you guys can see right here on the screen, I'm going to zoom in so you guys can see that a little bit better. When you look at problems like this, some students tend to think that it's very hard to do because you see a bunch of numbers and you're like, what am I supposed to do with all of that? Not make it difficult, that's for sure. Okay, so we did number 2 already on this particular part of the screen. So what I'm going to do, I'm going to actually do number 3. So let me go ahead and copy this. I'm going to screen share it back to where we were earlier. Okay, and I'm going to actually insert this problem down below. because I want to make sure that you guys can kind of keep up with what we're doing as we do practice problems of this nature, okay? Oops. Hold on, I didn't grab it. Let me grab it again. Let me copy that, okay? And let me go here. There we go. All right, so I'm going to actually crop this out, okay? So right here we're going to do number 3. So I'm going to crop out some of these problems because we don't need to focus on them. Again, we did number 2 already previously. If you missed number 2 here, you can go back and look at this again on my YouTube channel, okay? And it's under the lives, okay? Under the lives. So I'm just going to crop out a lot of this so we can go ahead and get straight to the problem that we need to do, and that's number 3. Okay, so let me crop out some more. Okay, so let me. All right, so now right here, okay, I'm going to scoop this down because I like to do a page a problem. Like I don't like to combine 2 problems on the same page because it just makes things a little more challenging to kind of decipher. Okay, so here we go. And look at those little bunny rabbits and those little eggs. I see that as you guys are liking the video, it's putting, I guess, because Easter is around the corner. So you got all these little Easter eggs popping off on the screen. Okay, y'all. I'm just cutting out the picture so that we can just zoom in on what we need to know. Okay, so yeah, that's what I'm doing. So I don't want y'all getting confused saying, what is all that? Okay, so here's this first problem right here. Now, although the answer isn't here for us to check it, this was, it should still be easy for you all to do. Matter of fact, I have my answer key, so I mean, I can show you proof of the answer as we finish it. But for this one, it says, calculate the delta H for the following reaction of sodium oxide with sulfur dioxide. Now, remember, you're given the 3 different compounds, okay? You're given 3 different compounds. So what do you need to do? You need to go to that chart that I showed you earlier and write them all out, okay? So this one, we need for sodium oxide, sulfur dioxide, and sodium sulfite, okay? So we need each of those, and we're going to check them off, okay? So let's scroll up here to the chart. Again, we're going to get rid of what we don't need. Okay, so if we go back up here, let's erase what we've already used because we don't need those. So we're just going to erase those because we don't need them. Okay, it doesn't want to erase. I don't know why. Okay, let me just put it in a different color. So we needed NaO, and there it is right there. So we needed Na2O, which is negative 414.2. We also needed Na2SO3, which is that number right there. And we also needed sulfur dioxide gas, which is this number right here. Okay, so we need those 3 numbers right there. Now I'm writing those down because I did not pre-work this problem out. So we're going to actually do this one together. Okay, we're going to do this one together. All right, so now let's scroll on to that particular problem. Okay, this is number 3 right here. All right, so we need to calculate the delta H for that particular problem. Okay, so let's see what we got to do. It's like what we said before, your products minus your reactants. Products minus your reactants. Remember, if there were coefficients, yes, you would do it. Yes, I've already done equilibrium problems, okay? I've done equilibrium problems already. They're on my page already and also on YouTube, not 4Z 3D. I've already done those. Yes, I did those about 2 or 3 weeks ago. So you're welcome. You're welcome. So right here for Na2O, okay, I'm just going to put the values over here so you all can see them. And sulfur dioxide and sodium sulfite. Okay, Na2O was negative 414.2 kilojoules per mole. And y'all, for space, I probably won't keep writing kilojoules per mole, but you know that the units are kilojoules per mole, okay? The next one was 296.8, again, kilojoules per mole. And then this last one was 1101 kilojoules per mole, okay? So again, you just go to your chart and and they're all negative, and that makes a difference, okay? That makes a difference in your answer. So just think if I left the negative sign off, what would have happened? We would have had some serious problems, okay? Some serious problems with this. All right, so all you got to do, remember, the formula is products minus reactants. Your reactants are on the left side, your product is on the right side. So what we're going to do, again, we're going to take the product. The product was negative 1101 kilojoules, okay, per mole, minus, okay, now remember, because we're bringing these things on the right-hand side, okay, we're going to change the sign. We've got negative 414.2 minus a 296.8. But remember, it becomes a positive because you have two negatives together, okay? And so you end up with 414.2, okay, plus 296.8, and that gives you negative 117.4. So you've got negative 1101 kilojoules per mole minus 117.4 kilojoules per mole. Okay, so you end up with, let's see here, 1101 minus 117.4, 1101 negative minus 117.4, and we get negative 1218.4 kilojoules per mole. So again, there's nothing to these problems, okay? You just plugging in your numbers. You're just plugging in your numbers. Oops, I made a mistake. I made a mistake. Who can point out the mistake? This is what I like about this teachable moment. Who can point out the mistake? What did Professor TK the chemist do incorrectly? Who can point it out? Who can point it out? I'm gonna see if y'all are paying attention, because I made this mistake on purpose to see if you guys are picking up what we're doing. Can you spot the error? So here's what I do on my test. Sometimes I will do a problem similar to this and say, is the solution wrong? Like to save the student steps to see if they can spot the mistake. Who can tell me where the mistake is? And again, remember, the delta H is equal to the sum of your products, okay, minus the sum of your reactants. So if we do our reactants right here, okay, the reactants was negative 414.2 minus 296.8, okay? And right here, you get negative 11. So for this part right here, okay, for this part right here, this should be negative 711, okay? So because we know that, okay, right here, because when you're doing the minus part, like you have to get the sum of those together, is negative 414.2 minus 296.8. You get negative 711, okay? Negative 711. Then when you bring this negative 1101 and you add these two together, because remember, you're bringing them together right here, you're going to end up with 1101, okay, negative, plus 711, because you're bringing it to the other side, and you get negative 390. Negative 390. So here's your teachable moment right here, guys, because I want you all to see this, okay? Again, I like to show mistakes because I know these are the mistakes that students tend to make. Right here, okay, these were your numbers here. These were your values that were given right here. These were the values that were given that I'm highlighting in red right here. These were the values that were given. Because you had the reactants right here, your reactants, okay, your reactants was negative 414.2 minus 296.8. When you get the sum of those together, it was 711. Now remember, when you cross on the other side, when you bring these values here from your reactants to the product side, their signs will change to a positive. That's where the plus comes from that I highlighted here in red. So you got negative 1101, which was the product result, plus the 711. And that's how you end up with negative 390, okay? What's confusing? What do you mean? What do you mean? It's confusing. Because here's the thing. Do I need to do it again? Start it over? Let me do it again. Let me start from the beginning. Because, you know, when students say they don't get it, I got to go back through it again because I want to make sure you got it, okay? I don't mind going back through it again. All right. Okay, so let me break it. Okay, Victor, these numbers here come from a chart. So you have to refer to the delta H chart for this particular unit. So these are not numbers you have to memorize. Your teachers may give them to you on your test like this and say, you know, use the values here to give your result, or they may tell you, here's a chart. Let me show you the chart so that way you're able to see it. Your teacher may give you the chart like this, and then you're having to go through and find the results, okay? You're having to go through and find the answer right here from looking at the chart. So this is a chart. So these numbers are not made up. This is a chart or a table. So now to answer the other question where they said this is kind of confusing the way I'm explaining it, let me go back through it again to make sure. Since these are the values that were given, okay, here's what I'm going to do. Let me break this down for you. If I say, for instance, I'm just going to do the problem without the further explanation part. Okay, you were given Na2O plus SO2 producing Na2SO3 solid, okay? Since you know the formula is reactants are on the left and the products on the right, you have to know that you're doing the sum of your products minus the sum of your reactants. And here's the deal though. On this side right here, the reactants, the numbers that were given, I'm going to write them underneath it, okay? You're going to take the negative 414.2 minus, because that's the sum of it, 296.8. Okay, these two were the numbers for your reactants right here. Over here for sodium sulfite, that value was negative 1101. Okay, get this value first right here. Oh, and by the way, this was your product. Okay, get this value here first. Negative 414.2, okay, minus 296.8. And we get negative 711. That's where you're reacting, okay? That's where you're reacting. This negative 1101 is your product. In order to get your delta H for this process here, you have to plug this into your formula right here, okay? Which again, it says your product minus your reactants. So I'm going to keep the product on that side, that negative 1101, okay? Because I'm going to bring this right here over to the other side, okay? That sign is going to change to a positive. That's where the plus comes from. And you're going to say 711 kilojoules per mole. And when you plug this into your calculator, thank you, Victor. I appreciate you. I really do. I appreciate you. You've got 1101, okay, minus plus 711. And that's where you get the negative 390 kilojoules per mole. Okay, so again, I just want to make sure that you guys can see what I'm saying, okay? So that way you guys are able to know that you don't need to make this hard, okay? Let me give you an algebraic way of looking at this. That way you can get what I'm saying, okay? In a different way. Sometimes you got to say it a different way. Okay, so if this is your formula right here, okay? You know you got X plus Y, okay, equals negative 1101 as an example. Okay. So if you got negative, okay, if you got X plus Y equals negative 1101, the formula is products minus the reactants. Delta H is equal to the sum of your products minus the sum of your reactants. So because my product here, okay, this is my product right here, I got these two together right here. These two were equal to negative 711. Well, you've got to add these two together. You've got to add these two together, the negative 711 and the negative 101. When you bring this negative 711 to the other side, that sign changes to a positive. Okay, so when I added these two together, it gave me negative 711. But because I have to use a formula, which is the negative 1101 minus the negative 711, those two minuses become positive. And that's how you get the number, okay? Or the answer. That's how you get your answer. Oh, thank you, Alexis. I appreciate you. I appreciate that. Thank you, thank you, thank you. Look, are you doing videos too, Alexis? Are you doing videos also? You know, I will send love your way too. Sometimes it takes students to pick up from other teachers, you know, and vice versa. And vice versa. So sometimes when I may not explain properly, I'll send my students to the tutoring center because sometimes they have to hear it from a different person. But I appreciate your support, you know, because it's all about the love here from one chemist to the other. Okay, let's do one more for the road, y'all. Okay, we're gonna do one more for the road. If you look at number 4, so let me go ahead and crop out number 3 because we've already done that one. Let me do number 3. I'm sorry, number 4. Okay, and let me scoot this back on down because it got up here. Okay, so number 4, it says use enthalpies of combustion to calculate delta H for the oxidation of L-butanol to make butonic acid. Okay, here's the deal. This is really simple, y'all. Okay, this is a review from what we did yesterday. This right here is what we want our formula to look like, okay? I'm highlighted it in this bluish teal color. So this is what we want our formula to look like. We have to make a decision when we look at these two chemical reactions here, okay? This is reaction number 1, and this is reaction number 2. Notice how the C4OH in this first chemical reaction is on the left side. So we're going to keep that one as is. We do not have to rewrite that one. We're going to keep that one as is. But notice in chemical reaction number 2, right here, the one with the little red stars by it, you're going to have to flip this one. And because we're going to flip that one, we're going to also change the sign to positive, okay? We're going to change the sign to positive. So I'm going to rewrite this first reaction, number 1. I'm going to write that one, C4H9OHL plus 6O2 gas produces 4 CO2 gas plus 5 H2O liquids. Now, because of space, I'm not going to write the number, okay, because of space. I'm not going to rewrite the number. And then the next one, reaction number 2, I'm going to flip this. So I'm going to start here with the 4 carbon dioxide plus 4 waters to produce the C3H7COOH plus 5 O2. Now, watch what I do. I'm going to cancel out what I don't need because everything is balanced. You see those coefficients? Everything is balanced. Remember, I had to change the sign to positive because I flipped equation number 2. So I'm going to cancel out things I don't need. You see the 4 CO2s? Cancel those out. You see your 6 oxygens here? You got 5 there, but guess what? We've got 1 left over up top. We're going to get rid of the waters, but guess what? We've got 1 more up top. So when we rewrite this, guess what we're going to do? On the left side, which is your reactants, I'm going to have what wasn't canceled out and what was left over. On the product side, we're going to write what was left over, and there you have it, okay? So now I'm going to fill in this by writing out the entire formula, C4H9OH plus that 1 oxygen that was left over up top, that 1 there, giving us C3H7COOH plus that 1 water that was left up top as well. And if you look at what the original reaction was supposed to be, guess what? There it is right there. That's what we wanted. And this is what we got. So now all you got to do is add those numbers. You're going to basically say negative 2,675.9 plus 2183.6. So 2675.9 negative sign plus 2183.6, and we get negative 492.3. Okay, the answer is negative 492.3 kilojoules per mole. Okay, that's the answer for that one. I told you, you're right. That's not bad. That's not bad. Here's the answer right here. See that? 492.3. Now, YouTube, you didn't see me put it up on the screen because my camera is off, but yes. What do you mean, Shar? What do you mean? Is this one of the types of questions you ignore solids in or no? No, you write everything out based on the way it's written. Okay. So, guys, this is it. The weekend is now here officially for me. So I will go live in April. So April starts, on Monday, April Fool's Day. I will be going live Monday through Thursday, still at 12 noon, okay, Eastern Standard Time. I still go live Monday through Thursday. So I'm gonna put this down here so y'all can see it, okay? But I don't know what time I'm going to go. Oh, yeah. You do ignore solids during equilibrium expressions. Thank you, Max. That is true. You do ignore solids when you're talking about equilibrium constants and expressions. Yes, happy Easter and Good Friday. That's correct. Yes, Julieta. Julita. I'm sorry, sweetie, if I'm messing up your name. Yes, but I will be going live Monday through Thursday, okay, 12 noon Eastern Standard Time. So if those of you guys that are wanting to get some extra help, you can see me next week. But also, I'm still determining what time I will go live in the evening time, okay? Because I know we're getting to the end of the semester and so many students are in panic mode. So if I do go live in the evening time, thank you. I'm so glad you found me too. If I go live, when I go live, and it's not if, but when I do, it will either be between 7 p.m. Eastern Standard Time or 8 p.m. Eastern Standard Time. But we will see, okay? Yes, I know how students are, Alexis. Oh, I get it, honey. I get it. And students are in panic mode because if they did not start off on the right track at the very beginning of the semester, we know what happens. I try to So YouTube, it just kicked me off over there. But I try to go live every day, Monday through Thursday. But for those of you all that are here, I will be doing this in the evening time at either 7 p.m. or 8 p.m. Okay? At either 7 p.m. or 8 p.m. I'm going back on TikTok. I don't know why it kicked me off. It just kicked me off. But yes, I will be going live 7 p.m. to 8 p.m. So you guys have a wonderful rest of your day and weekend. Be safe, be careful, take care of yourself, and most importantly, do what you got to do with what you have and give yourself some grace.